Good day, everybody. Here you are once again. This is a 20-point tutorial, and this is the chemistry class. We are now into a new section. I welcome you all once again. We want to consider something important today. We want to see examples on balancing of redox equation in acidic medium. Today we are going to handle this aspect only in acidic medium. Later on, we'll come next time, we'll talk about in basic or alkaline, or like I say, neutral medium. Now we want to see some few questions I've already written down. The questions before us are: 1. Balance the following equations in acidic medium. The first one here is a redox. All of them here you see they are all redox equation that are not yet balanced. Here we have to say, to do the balancing, we can say here iron 2 plus iron ion, manganese ion. Then we talk about the product side to balance it. Pick the first one now. Let's see the solution. The pattern to follow has been given in the previous class. And the steps. The first one we need to pick up here is iron 2 plus reacting with this iron manganese ion, yielding to iron 3 plus and Mn2 plus. The first thing to do, like I said before, is to kind of split the equation. You split it into two halves. One of the half represents the oxidation half reaction, and the other half represents the reduction half reaction or reduction half equation. This method we are applying, remember, is known as the half cell, or you can call it the half equation or the half cell method. The half cell method or the half cell equation. Come back to the board here. Let's see what we have. The splitting now goes this way. Iron 2 plus at the left hand side, at the reactant side, then changes to iron 3 plus at this side, at least from here to here. What we notice now is that the oxidation number of iron has increased to +3, from +2 to +3. That is called increase in oxidation number, and that's also known as oxidation reaction. Oxidation reaction. Oxidation reaction going on here. Then on the other hand, the manganese MnO4 minus changes to Mn2 plus. That means the removal of oxygen from MnO4 minus means reduction reaction. Or now we look at manganese ion, MnO4. In MnO4 ion, manganese has an oxidation number of +7. Now it has reduced to +2. That is reduction reaction. Decrease in oxidation number. So we can call this side reduction reaction. This is the reduction side. Reduction reaction. Then we move on to the next aspect. That is the sharing, the splitting. The first one now would be this. Iron 2 plus has been oxidized to iron 3 plus. Iron 3 plus, Fe3 plus. This is called the oxidation half equation. Oxidation half equation. For the oxidation going on here. Then for the other side, we have MnO4 ion that has been reduced to Mn2 plus. This is called reduction half equation. The reduction side, the reduction half equation. Then the next thing, let's go on to the side of balancing. We said the first thing to do is to balance the central atom. Now pick up the first one. Let's balance up this. Let's go on with iron 2 plus. Iron 2 plus yielding iron 3 plus. Now what we see here, iron 2 plus, iron 3 plus. What can we consider here in this very aspect? Looking at it very well, we understand here that in the aspect of balancing of the atom, ion here, one ion here, one ion here is already balanced. The atoms are already balanced left and right. Then let's come to the aspect of balancing of the oxygen. Do we have any oxygen here? Any oxygen here? No. When we are done with the aspect of balancing of the charges, of the atoms, number of atoms at the left hand and the right hand side are equal. Then come to the aspect of balancing of the oxygen. Is there any oxygen here? Here? No. So leave that aspect. If there was an oxygen here before, then we will have to do the balancing of oxygen. Now there's no oxygen at the left hand side and there's no oxygen at the right hand side. The next step now is the hydrogen. When we are done with the oxygen, go to the hydrogen. Is there any hydrogen at the left hand side or at the right hand side? No. So we leave that aspect. The next thing now is balancing of charge. When we are through with balancing of central atom, balancing of oxygen, then balancing of hydrogen, then we will go to the next step. That is balancing of the charge. Let's consider the charge. Since there is no oxygen to balance, there is no hydrogen to balance now. For the charge, are the charges balanced? No. At the left hand side, the total charge is +2. That is 2 plus. At the right hand side, the total charge is +3. That is 3 plus. Then what do we need to do right now? Balance the charge. And to balance the charge, we need to go to the side that has the higher charge. The side that has the higher charge, that is where we do the balancing. We need to reduce it by adding electron. And whenever you are adding electron to any side, the reason why you want to, the purpose of adding electron to a charge is to reduce the charge. Is to bring the value of the charge down. Like now, this +3. To bring this +3 to +2 is to add +1 to it. And we have to understand here that electron has a charge of -1. Let's assume that anytime you see electron, you just see it regard it to be -1. Just take it to be -1. So when you are adding electron to +3, it means that you are adding -1 to +3. And -1 plus 3, adding -1 to +3, that gives you +2. That gives us +2. So right here, the question now is which side has the higher charge? Is the right hand side. So that's the side we go to and add the electron. We go to the right hand side, then put an electron there. How many electrons should I put? Just only one electron. So that you can bring it down to +2, so that it will equalize the charge at the left hand side. So we just need an electron. Then what we do right now, it implies here that ion 2 plus yields ion 2 plus yields ion 3 plus an electron. Then right here we can say that this oxidation reaction is already balanced, because let me just call this equation 1. Let's call it equation 1. Then for the other side, for the second equation, the reduction half reaction, we have MnO4 minus yielding Mn2 plus. What do you see here? What can you understand here? What can we bring out here? Look at it very well. We need to balance the atoms. How many atoms? Start by balancing the atoms, then we not go forward to do the balancing of the oxygen. Then after that, balancing of the hydrogen. Then after that, the balancing of the charge. The question is how many atoms of this are here at the left hand side and at the right hand side? How many atoms of this are at the left hand side and at the right hand side? Now look at the manganese here. Right at the left hand side we have one manganese, one atom of manganese, and at the right hand side only one. So manganese is already balanced. But for oxygen, we have 4 oxygen. Now then go to the side that lacks oxygen, as the deficient side. Then what do we do? Remember I said last time, based on the steps in our former class, we said in acidic medium, based on the steps, you need to add 1 molecule of water to the side that has no oxygen or lesser oxygen. Like now you can see this side, the right hand side, has no oxygen. That is the deficient side. The side that is deficient of oxygen is lacking oxygen, or it has lesser oxygen. Then we go to that side and add water molecule, and it is based on the number of oxygen at the right hand side. Here we have 4 oxygen at the right hand side, so it means that we need 4 water molecule to add to the right hand side. Because, why is the reason? Why are we doing that? Because at the left hand side we have 4 oxygen atoms, and you know it is the water molecule we use in balancing the oxygen at the deficient side. So what we need to do right here, how many water molecule, how many H2O we need to add to the right hand side? It is based on the number of oxygen. Since we have 4 oxygen atoms, so we need to write 4 water molecule added to the right hand side. Know why? Because 4 times the O here, the oxygen here, will give us 4 oxygen, which now balances the right hand side. So go this way, 4 H2O added to the right hand side. That means we have gotten equal number of oxygen at the left and at the right. 4 times oxygen is 4 oxygen. We have 4 oxygen. But something has come up, a challenge has come up now. At the right hand side, we now have 8 hydrogen atoms. 4 times 2, that's 8 hydrogen atoms. But at the left hand side, we don't have any hydrogen. It's a deficient side. So we need to go to the left hand side and balance up the number of hydrogen that we have at the right hand side. Balance up, we add a particular amount. And what we need to do, what we add to the left hand side, so as to balance up the hydrogen we have at the right hand side, the 8 hydrogen. What we use in balancing number of hydrogen at the deficient side is hydrogen ion, H+. That is hydrogen ion. We make use of hydrogen ion. And the question is, how many hydrogen ions we use, how many H+ we use to balance up the hydrogen at the right hand side? Since we have 2 times 4, 8, since we have 4 hydrogen atoms at the right hand side, so it means that we need 8 hydrogen. Since we have 8 hydrogen atoms at the right hand side, we need 8 hydrogen ion at the left hand side. So we can add to the left hand side, then we make it equal in number. The number of hydrogen here and the other side will now be equal. So we go this way. Now. It implies that MnO4 minus plus 8H plus ion, hydrogen ion, yields Mn2 plus 4H2O. Now we have this. This is not, well, then we are not yet through. Remember, we said we balance the atom. After balancing the atom, we balance the oxygen. After balancing the oxygen, we balance the hydrogen. Then after balancing of the hydrogen, we go to the next stage, balancing of the electrons, the charges. The charges will be balanced. At the left hand side, we have equal number of hydrogen and at the right hand side, equal number of oxygen at the left hand side and at the right hand side. We have equal number of manganese at the left hand side and at the right hand side. Then what to do right now in the charge? What we consider, let's consider the whole charge. The total charge at the left hand side. Right here we have -1 and right here we have plus, but this is 8 times plus 1. Ordinary plus means plus 1. So we say 8 times plus 1 means plus 8. So -1 here from this side is -1, while from this side is plus 8. -1 plus 8, that gives me what? Plus 7. So right now at the left hand side we have plus 7 as a charge. Then the total charge at the right hand side is plus 2, because right here is 0. The charge here for 4H2O is 0, while this one is plus 2 plus 2. So the total charge at the left hand side is what? Plus 2. So there's an imbalance in the number of charge. For the left hand side plus 7, for the right hand side plus 2. What we do next is to balance, equalize the charges. The charge at the left hand side and the one at the right hand side. How do we now do the equalizing of the charge? It's electron. We need to add electron to the side that has higher charge. Plus 7. We need to add. Then the question is, how many electrons should I add to plus 7? We need to look at it right here. Plus 7, let's say this way. If I must bring plus 7 down to plus 2, we need to actually remove 5. Minus 5 means 5 electrons. Minus 5 taken away from 7 is plus 2. Minus 5 taken away from plus 7 is plus 2. That means I need to add minus 5 to 7 to get plus 2. And that minus 5 means 5 electrons. So whenever you see minus 5, it means 5 electrons. Like last time we said minus 1 means 1 electron. So minus 5 now means 5 electrons. We cannot say here that we need to add 5 electrons to the left hand side so I can equalize the charge. We will now go this way. MnO4 minus plus 8H plus 5 electrons yields what? Yields Mn2 plus 4H2O. That is, now this one gives us equation, let's call it equation 2. Equation 2. Then the next thing, look at equation 1, look at equation 2. When you consider equation 1 and equation 2, something should be done. We need to consider equation 1 and equation 2 very well. Equation 1 is balanced, equation 2 is balanced, completely balanced. Electrons are balanced, charges are balanced, then the oxygen is balanced, hydrogen is balanced, number of atoms left and right are all balanced for equation 1 and equation 2. The next thing to do, pick up, look at the electrons. At the equation 2, the electron here has a coefficient of 5. That's 5 as a coefficient. Right here, in equation 1, the electron has a coefficient of 1. So you pick the coefficient of this electron here and take it, or that's 1, use the times equation 2. Then pick the coefficient of the electron in equation 2, that's 5, and take it up and use the times equation 1 all through. Now look at what we have. Let's go this way, just like this. Look at the illustration now. You say 5, picking equation 2 electron, and the coefficient is 5. Pick it up and use it to times the whole of equation 1 as you are interchanging. 5 times what? Ion 2 plus yielding ion 3 plus electron. Then taking the coefficient of the electron in equation 1, take it up and times equation 2 as 1 times manganese MnO4 ion plus H plus 8H plus 5 electrons yielding Mn2 plus 4H2O. Then when we are done with that, the next thing to do right now is to do the multiplication. 5 times everything here, 5 times 5 electrons, 5 times 5 electrons, we have 5 electron, 5 times 5 ion 2 plus is 5 ion 2 plus, then yielding, then 5 times 5 ion 3 plus is 5 ion 3 plus 5 electron. 5 times 1 electron is 5 electron. So we call this one equation 1 changes to equation 3. Then we have 1 times everything here is 1, everything. 1 times this is this. 1 times 8H plus is 8H plus. 1 electron is 5 electron. Then 1 times Mn2 is Mn2. 1 times H, 4H2 is 4H2. So everything, just a kind of repetition we have here. And I believe you are following up. This is turning point tutorial. Get along with us. Then the next one here, MnO4 minus plus 8H plus 5 electrons yielding Mn2 plus 4H2O. This is equation 4. So equation 2 has changed to equation 4. But now we have new equations 3 and 4. Now that we are through with this aspect, the next stage to go into is the adding. Like I said before, we have done that. We now add up the equation 1, equation 2 has changed to equation 3 and 4. All that we have done here is interchanging the coefficients of the electrons, then times through, multiply through. Then we have new equations formed 3 and 4. Then what you're going to do at this stage after this is to add the reactant of this equation 3 to the reactant of equation 4. Then yielding, then you add the product of equation 3 to the product of equation 4. So that means you are saying reactant plus reactant, yielding products plus products. Then what we now have at the end of the day will be a longer equation. Something like this. Let's go this way now. We have something like this. A new equation is formed. Only one equation. That's a combined equation. Look at it right now. This one, you write it down. We have 5 electrons if I say 5 iron 2 plus, then right here plus this reactant plus this reactant plus MnO4 minus plus 8H plus then you have 5 electrons yielding what? Then this the right hand side iron 5 iron 3 plus then we have this one coming up Mn2 plus then plus what again? We have 4H2O then we also have plus 5 electrons. This one gives us the combined one, but the next thing now to do, like I said before, is there any species that is repeating itself as appearing on both sides at the same time? Like now, you consider there's no one except electron. Electron is at the left hand side, and there's another electron at the right hand side. Electron here, then we cancel out the electron. 5 electron and 5 electron here that are equal at both sides, so we slash them out, slash this one out. Then is there anyone again? No. You can see MnO4 is here, but we don't have MnO4 there, so we cannot slash it out. We have 8 hydrogen plus here, we don't have any hydrogen plus, H plus there, so we cannot slash out. And then for the 5 iron 2 plus, there's no that iron 2 plus at the right hand side, so they cannot slash out anything in that aspect. Then we can see 4H2O, 4 water molecule, but there's no water molecule here, so we cannot slash out anything. At the final analysis, this is a balanced Redox equation. We cannot go this way. That the balanced Redox equation before us is this. We can write it out. The balanced Redox equation for question A is 5 iron 2 plus MnO4 then plus 8H plus 5 electrons, plus then 8H plus, then we have yielding what? 5 iron 3 plus, then we have Mn2 plus, then plus the other one which is 4H2O. That's a balanced equation. This one's already balanced. Then we come to the other one, which is the equation, this very equation here. But let me just give you an instance. Now you can see, I'll break it up for the equation. For this second equation, I won't give you everything. I want to do a completion. You complete everything by yourself, but I will take you through halfway and I will stop there so you can do the rest yourself. Now let's look at these aspects. I believe you have taken this one. Please understand. Number 2 is your own, for you to do, you do it yourself, your own personal assignment. But for this one, I will split it out for you, then take it through like that. Now you have this one written here, please take it down before I will go through. This one here, we have, let's go this way. Right now you have, take it down, we have to say, for this, which one is oxidized, which one is reduced. Going from here to here, you understand that this Cr2O72 minus is being reduced to Cr2 plus. Why this side? So this one is called reduction reaction. This is a reduction half reaction or half equation. And then why this side, going to this side, from this side to this side, we call it what? Oxidation half equation, oxidation half equation. So we split it now the very way. The first one will be like this, will look like this, Cr2O72 minus yielding Cr3 plus as chromium ion, chromium 3 plus. Then the other one which is SO2 yielding what? Yielding SO42 minus, that is sulfate ion. Then what we do right now is right at the right hand side put reduction reaction, half reaction. Then this side is called the oxidation half reaction. Oxidation half reaction or half equation. Then when you are done that, what you do right now, look at the first one, you pick this one up, just to help you a little. You pick this one up and then you consider Cr2 O7 2 minus, then yielding Cr3 plus. Look at this side now. This one lacks, this side has oxygen, but this side, for the first thing to do is there is the chromium. Number of chromium we have here is just 2. So we need to put a 2 here. Now we have 2 chromium here, so we need to put 2 here to balance up the number of chromium atoms. But for the oxygen, we have just have 7 oxygen, but the right hand side there's no oxygen. Now to balance up oxygen, what I told you last time is use water molecule. But it's based on the number of oxygen atoms you have here. How many oxygen atoms do we have here? We have how many? We have 7. So since we have 7, we need to add up 7 water molecules. That means you have gotten how many of oxygen now? You have 7 oxygen, but 14 hydrogen. So to balance up the hydrogen, what you're going to do right now is to say 7 times 2, that's 14 hydrogen. So you make use of what? You make use of 14H plus to balance up the hydrogen. So you come back this way, you say Cr2O72 minus plus 14H plus use what? It used 2Cr3 plus 7H2O. Then that of the other one, you go this way, SO2, then yielding this one now have to then for this one, let me just even help you by saying, at least I've tried in helping you to get that of the balanced aspect of the atoms, but the charge, I've told you before how to balance the charge. When you balance the charge, check the total number of charges you have here, and then you look at the right hand side, then balance up. When you do the balancing, then you see that you are done with equation 1. You can now use that one. After balancing the charge, you have gotten equation 1 done. Then you go to this side, do the same thing here. You will do the balancing of the sulfur, then do the balancing of the oxygen. The side that has lesser oxygen, go to that side and do the addition of the number of oxygen there. Then when you have done that, balance the hydrogen, balance the charges. Then when you are through with that, do all the balance addition, then follow the procedure we have here. You will have a perfect balanced equation for that of question B. Then that of question 2, go on your own, find out how you can mesh everything together and have a balanced redox equation. This is just the steps the steps you can follow, the pattern you apply when balancing a half cell equation, 2 different half cell equations. So please, this is a turning point tutorial. You will have enough of questions like this. Please go ahead, solve more questions. If you have any difficulty, call us and then we will chat with you on WhatsApp or give you a video that will give you a solution to all this. Thank you very much. We'll see you in the next class. Thank you.